Geometry, Chapter 6, Section 4, Properties of Special Parallelograms. Pause the video and warm it up. Come on back and check your work. And x equals 4. And x equals 47. And again, we know parallelogram has opposite congruent segments, right? So CD is 14 when you solve for y, right? And then you substitute. And the measure of angle C must be 104. Today, we will prove and apply properties of rectangles, rhombuses, and squares. We will also use properties of rectangles, rhombuses, and squares to solve problems. Okay, vocabulary, nothing too tricky today. Okay, today a type of special quadrilateral that we will talk about is a rectangle. So yes, a rectangle, you know, is a quadrilateral with 4 right angles, right? So this is known as rectangle ABCD. So let's look at 2 theorems for the properties of rectangles. So we know that if a quadrilateral is a rectangle, then it is a parallelogram. If it's a rectangle, then it's a parallelogram. So we could say that rectangle ABCD is a parallelogram. And if a parallelogram is a rectangle, then of course its diagonals are congruent. So AC is congruent to segment BD. So a rectangle is a parallelogram. It then inherits all the properties that we know parallelograms have. A woodworker constructs a rectangular picture frame so that JK is 50 centimeters and JL, J all the way to L, is 86 centimeters. We're asked to find HM. And I bet you can do it like that. Snappy, snappy, right? But let's do it in the form of a little proof. We know that KM is congruent to JL. KM is congruent to JL because if it's a rectangle, then the diagonals are congruent, right? So now we can probably substitute, right? We can substitute 86 as the measure of both KM and JL. We know that JL is 86, it's given, and by definition, we have congruent segments have equal measures. So what else do we know about the diagonals of a rectangle? Yes, we know that HM would be half of the longer diagonal KM. HM is half of KM because in a parallelogram, the diagonals bisect each other. So all we have to do is take half of KM, which we know is 86. Just substitute that in, right? And what do we have? 43. Substitute and simplify. Okay, in question 2, we have a rectangular gate that has diagonal braces. Find HJ. And your answer is 48, right? Good. And that's just by definition, isn't it? HJ is congruent to segment GK. Rectangles have diagonals that are congruent. Wait a minute, HJ. These are just, rectangles are parallelograms. So this should say they're parallelograms, so opposite sides are congruent, right? Oh, once again, the key is not quite accurate here. Anyway, HJ equals GK, and that is our definition of congruent segments of a parallelogram. Okay? So now let's talk about the diagonals. The rectangular gate has diagonal braces, so find HK. Now we can talk about the diagonal, right? And go ahead and see what you can come up with. All right, this 30.8 inches is representing J to L. J to L. And because we have a rectangular gate, we know that the diagonals bisect each other. And so JL must be half of JG, and JG must be congruent to HK. So you probably have 30.8 times 2, right? or 61.6, right? 61.6. And here you can pause and take a look at this proof. I'm sure what you have come up with. Our next special quadrilateral is one which has 4 congruent sides. And do you remember the name? I know you do. Rhombus, right? A rhombus is a quadrilateral with 4 congruent sides. So we have a rhombus named ABCD here. Let's look at a few properties of rhombuses. So first we can say that if a quadrilateral is a rhombus, then the quadrilateral is a parallelogram. Okay, so it inherits the properties of a parallelogram, such as opposite sides are congruent and parallel, right? And opposite angles are congruent. We have bisecting diagonals and so on, right? If a parallelogram is a rhombus, though, its diagonals not only bisect, but they are perpendicular bisectors. Isn't that cool? AC is perpendicular to segment BD. And if a parallelogram is a rhombus, then those diagonals bisect the opposite angles, right? So each diagonal bisects the angles at its endpoints, basically. So diagonal BD bisects angle B and angle D. And so because the entire angle ABC is congruent to CDA or ADC, then all of these angles are congruent. Isn't that neat? That's cool. Okay, very good. Okay, we've already said this, that you can apply the properties of parallelograms to rectangles and rhombus. So let's see what we can do here. We are going to use properties of rhombuses to find the measures. Okay? We're asked to find TV. TV. And so why don't you pause and think about this. We're told it's a rhombus, right? And we don't know TV and we don't know WX, but we do know XT, that length, and we do know WV. And we know it's a rhombus, so what do we know about these two expressions? That's right, they must be equal, right? So what can we find? We could find the unknown B, right? And once we find it, after setting these two expressions equal, we can substitute the value back into either and get that length, which will also equal TV, right? So we know that WV is equal to XT, the definition of a rhombus, so we can substitute the given values. And if you haven't already, pause and find the value of B. So we subtract, and B is 1.3. Okay? And now we can say that TV is equal to XT because of the definition of a rhombus. So we can simply plug the 1.3 back in and find that 7.9 is the length of each side, right? Every side here is the length 7.9. Let me bring this back down so we can see the entire measure. Excellent. Good job. Okay, so let's find the measure of angle VTZ. Now, angle VTZ is created by this diagonal TW, isn't it? And we know that that diagonal also creates the other congruent angle, which would be WTX. And here is the expression 5A minus 5, right? So if only we knew A, we could substitute that value into this expression, and we would then know this small angle, which is congruent to VTZ. Okay, so how do we find A? We have this other expression for the angle in here, the angle TZV. And what do we know about that angle? Yes, that angle is right, because the diagonals of a rhombus are perpendicular. So can we find A? Absolutely. We can substitute that expression 14A plus 20 for the angle and solve for A. Let's do it. Subtract your 20, divide by 14, and A equals 5. So if we're going to find our angle, we can state that, again, the angle VTZ equals the measure of angle ZTX, as I said. So let's go ahead and substitute that expression. And we'll substitute our known value A, right? And what do we have? We have 20 degrees. Good job. So the missing angle is 20 degrees. Okay, let's combine both of these special quadrilaterals into one extremely special quadrilateral. A quadrilateral with 4 right angles and 4 congruent sides is a square. That's right. So we will show that a square is a parallelogram, a rectangle, and a rhombus. So the squares, they have properties of all 3. This is square ABCD. So rectangles, rhombuses, and squares are sometimes referred to as special parallelograms. Show that the diagonals of square EFGH are congruent perpendicular bisectors of each other. Okay, so we'll have to look at length to find congruent segments, right? And we might have to look at our slopes to find perpendicular bisectors, right? So we show that EG and FH are congruent using our distance formula, and lo and behold they are, right? And we can also show that EG and FH are perpendicular given that they have negative reciprocal slopes. Okay? We can show that EG and FH bisect each other by looking at midpoints. Since EG and FH have the same midpoint, they must bisect each other. The diagonals are congruent, perpendicular bisectors of each other. So we have shown that the square is, let's look back at the square, has diagonals that are congruent and perpendicular bisectors of each other. That's really cool. Very good. And one last question before you move into your lesson quiz. Can you prove that AEFD is a parallelogram with the given information? Okay, you can start with all the given information in one statement given, and then see what you can come up with, and then pause, come back and check. Again, there might be more than one correct proof, but because we have a rhombus, we can say that ABCD is a parallelogram by definition of rhombus, right? A rhombus is a parallelogram. So we can say that AE is parallel to FD. That's our definition of a parallelogram. AE and FD. Good. And so now what can we say next? We can say that AB is congruent to CD, and that is because a parallelogram has opposite sides that are congruent, right? What can we say next? About AB is equal to CD. That's our definition of congruency. So AE is half of AB, and FD is half of CD, definition of midpoint, right? And we were given the fact that we had midpoints, so now we're just using the definition of midpoint. Good. Next, we could say that FD equals half of AB by substitution, right? And that's given these 2 steps up here above. Combining them together, we have substituted, right? So AE equals FD, okay, and that's by substitution. We can plug that in right here. Transitive property, right? If AE equals half of AB and FD equals half of AB, then AE equals FD. Transitive property, congruency. We can say that segment AE is congruent to FD, right? Segment AE is congruent to FD, and that's definition of congruency. And finally, we can say, whoops. So AEFD is a parallelogram because a quadrilateral with one pair of opposite sides that are congruent and parallel is then a parallelogram. Okay, pause the video and, oh, I'm sorry, we have one more. Okay, why don't you just pause the video and come up with 7 statements in your proof to show that segment RQ is congruent to RS, and then come back and check. Okay, if you're back, then you should have something like this. And to wrap things up, try this lesson quiz. Come back and check your work. TR is 35 feet, and CE is 29 feet. And part 2, number 3, QP, pause, come back when you're ready. QP is 42, and the measure of QRP is 51 degrees. Okay? And this takes a little bit of work. You know, we've spent a lot of time already on 2 like this, so you can just check at this and try it if you have time. Otherwise, you can go straight into your assignment. Here's another one that you can take a look at and read through. I want you to get right into your assignment and get going. Okay? Good job.